Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In this first video lecture of week 13 for the course Applied Linear Algebra, today we are going to discuss equation of plane in 3D space. In the previous video lecture, we have discussed equation of line in 3D space, and now today we are going to discuss equation of plane in 3D space. For the equation of plane in 3D space, consider the plane containing the points P whose coordinates are x0, y0 and z0, and the normal vector n whose components are a, b and c. And this normal vector is perpendicular to the plane, and you see over here in this slides, this is a plane in 3D space, x dimension, x direction, y direction and z direction. So this is the plane. P, Q are the points of the plane, and this is the normal vector to the plane. So dear students, you see over here P0 is the initial point, in Q is the another points on the plane. So this PQ vector is orthogonal to the normal vector. PQ is perpendicular to this normal vector. So we are going to find the equation of plane in 3D space. So since you see over here in these pictures, these two vectors, PQ vector and the normal vector, this n vector are perpendicular. So the plane consists of all points Q whose components are x, y and z, for which the vector PQ is orthogonal to the normal vector n whose components are a, b and c. Since PQ and n are orthogonal, then the following equation hold. We know that when two vectors are perpendicular, then their dot product is equal to 0. So n dot PQ vector is equal to 0. Now the components of n vectors are a, b and c, and similarly PQ mean q minus p. So subtract the p term from the q points, subtract the q coordinates to the p coordinates, we obtain x minus x naught, comma, y minus y naught, comma, z minus z naught is equal to 0. Now by using the dot product, multiplied the components, this first component to the first component of this vector, a into x minus x naught plus b into y minus y naught and plus c into z minus z naught is equal to 0. So dear student, you see over here, this is the scalar form which is called equation of plane. This gives the standard equation of plane. If we expand this equation, we obtain the following equations: ax plus by plus c is equal to ax naught minus by naught minus cz naught. If we consider, suppose this is equal to d, ax naught minus by naught minus cz naught is the constant. So suppose this is equal to d, ax naught minus by naught minus cz naught is equal to d. Then this gives the general form of equation plane in 3D space. You see over here, ax plus by plus cz plus d is equal to 0. So we summarize these results as follows: standard and general form of equation of plane in 3D space. The standard form of plane in 3D space has the form a into x minus x naught plus b into y minus y naught plus c into z minus z naught is equal to 0, where x naught, y naught, z naught is a point on the plane and n is the normal vector whose components are a, b and c. As a vector, normal are orthogonal to the plane. If this equation is expanded, we obtain the general equation of plane of the form ax plus by plus cz plus d is equal to 0. So dear students, note that to write equation of a plane in 3D space, we need a point on the plane and a vector, normal vector, orthogonal to the plane. So then we can find easily equation of plane when one point of the plane and one normal vector of the plane are given. So now intersecting two planes, some planes, intersecting planes. Suppose we are given two intersecting planes with angle theta between them. So you see over here plane number 1 and plane number 2. These two planes intersect each other. So there will be an angle theta for these two planes, and you see over here this is the normal vector of the first plane, and n1 is the normal vector of the first plane, and n2 is the normal vector of the second plane. So when two planes intersect each other, then we can find the angle by let n1 and n2 be normal vectors to these planes. Then cos theta is equal to n1 dot n2 divided by n1 magnitude n2 n2 magnitude. Thus two planes are perpendicular if n1 dot n2 is equal to 0. If the normal vectors of the planes are perpendicular, then planes will be perpendicular, and which implies that theta is equal to pi by 2. Similarly, if these two normal vectors n1 and n2, if these two vectors are parallel, these two vectors will parallel if one vector is a scalar multiple of other vector. Suppose you see over here n2 is equal to c n1, where c is a scalar, so n2 is the scalar multiple of n1. So in this case n1 and n2 are parallel. So if these two vectors are parallel, then the planes will be parallel. The planes does not intersect each other anywhere. And note that given the general equation of plane ax plus by plus cz plus d is equal to 0, the normal vector is n, a, b and c. The intersection of two planes is a line. The intersection of two planes is a line. So dear students, in this slide you see here three most important points. Cos theta, by this formula we can find the angle between the normal of the vectors, and if these two vectors n1 and n2 are the perpendiculars, then the plane will be perpendicular, and the theta between the plane will be pi by 2. And if these two vectors are parallel, and when these two vectors will be parallel, if one vector is the scalar multiple of other, then planes will be parallel. So for the general solution for the general equations of plane, we need one points on the plane and we need one normal vector. And you see over here now the distance between points in a plane. How we can find the distance between a point and a plane? Suppose you see over here, this is a plane and this is the normal vector. Suppose we are given a point Q not in the plane, this is outside the plane, and a point P on the plane, the point P on the plane. In our goal, our purpose is to find the shortest distance between the point Q and the plane. So the distance between the point Q and the plane by projecting the vector PQ onto the normal vector N, calculating the scalar projections components of PQ along N, we can find the distance D by using this formula. Distance between Q and the plane, distance between the point Q and the plane is represented by D, and this is equal to the magnitude of this vector. Projection of PQ. PQ is the vector P vectors, components of PQ along N, and this is equal to PQ vector dot N vector divided by N magnitude, and this is actually a scalar quantity. So this is the distance between the points Q and the plane, and we can find the distance now by this formula: ax1 plus by1 plus cz1 plus d divided by a square plus b square plus c square. So this is the distance formula. between the point and the plane, where x1, y1 and z1 are the points of the plane. Ax1, x1 plus y1 plus z1 is the Q point, which is above the plane. So we need to find the distance of this Q point on the, to the plane, the distance between the Q point and the plane. So suppose the Q coordinates are x1, y1 and z1. So just putting the coordinates of the Q points in the general form of equation of plane, ax1 plus by1 plus cz1 plus d. Actually the equation of plane is ax plus by plus cz plus d and is equal to 0. So just put the values of the Q points coordinates x1 in place of x, y1 in place of y, and z1 in place of z. So replace x by x1, replace y by y1, and replace z by z1, and divide by this is the magnitude modulus, divide by a magnitude. This is the coefficient of x, coefficient of y b square, and coefficient of z c square. So this is the distance formula of the plane and the point outside the plane. So note there, to find the distance d between the planes, we choose any points on one plane and calculate its distance to the other plane. So when two planes are given, actually in this slide you see over here, one plane is given and one points Q which not lies on the plane is given. So we find the distance between this point to the plane. But when this point is not given, suppose two planes are given, then how we can find the distance between the two planes? So first of all, choose any points on one plane and then calculate the distance between their points and the other plane. So we can easily calculate the distance between the two planes. So dear students, in this lecture you see over here, the conclusion of this lecture is how we can find the equation of plane in 3D space. For the equation of plane in 3D space, you see over here, one point for the plane and one normal vector for the plane is required for the equation of plane in 3D space. So PQ is one vector and N is another vector which is orthogonal to this vector. So these two vectors are perpendicular. So just take the scalar product, the dot product of these two vectors, you will get the equation of plane. So this is actually the equation of plane in general form, and this is the equation of plane in standard form. A into x minus x naught plus b into y minus y naught plus c into z minus z naught. This is equation of plane in standard form, and after simplifications we obtain ax plus by plus c is equal to minus ax naught minus by naught minus cz naught. If we suppose this is equal to d, then ax plus by plus c plus d is equal to 0 is the equation of plane, general equation of plane. So this is actually called general form of equation of plane. You see over here in this slides, this is the standard form of equation of plane and this is the general form of equation of plane. So for the equation of plane, we need just one point on the plane and we need one normal vector. But sometime when points of the plane are given and normal vector not given, then take any two vectors from these points and construct the cross product of these two vectors. You will obtain the normal vector for the plane easily. So dear students, in this video lecture I told you about the equation of plane in 3D space. For the equation of plane, we need one point and one normal vector for the plane. And how we can find the distance between the planes? If two planes are given, then choose one point for one plane and then find the distance between the points and the other plane. But when one point is already given, and one plane is already given, then we can easily we can easily find the distance between the plane and the point by using this formula. Just replace x, y and z by the points x1, y1 and z1, and take the square of the coefficients of x, y and z and plus under root. So under root square root of the sum of the squares of the coefficients of x, y and z. So this is the distance between the points and the plane. And how we can find the angle between two planes? You can use this formula, angle between two planes. First of all, choose the normal vectors for the plane and use this formula: n1 dot n2 divided by n1 magnitude n2 magnitude. This is the angle formula between two planes. And inshallah, in the next video lecture, I will tell you about some numerical problems related to the equation of plane in 3D space. And now this is the end of this segment. Thank you. Allah Hafiz.